Hello again, fourth grade, and welcome to lesson 12-3, where we're going to talk about comparing decimals. So when we're comparing, we're using our greater than, our less than, and our equal to symbols. All right, let's go ahead and get started with our lesson video.
How do you compare decimals? Think about this question during the lesson. Donovan ran the 100-meter race in 10 and 11/100 seconds. Sal ran the same race in 10 and 9/100 seconds. Who had the faster time? There is more than one way to compare decimals when they refer to the same whole. One way is to use hundredths grids. For 11/100ths, there is 1/10 column and 1 unit square shaded. For 9/100ths, there are 9 unit squares shaded. When you compare 10 and 11/100ths and 10 and 9/100ths, the digits in the tens and ones places are the same. Compare the digits in the tenths place. 10 and 11/100ths is greater than 10 and 9/100ths. Who had the faster time?
Select your answer.
Sal had the faster time.
The smaller decimal is the faster time.
Another way to compare the decimal numbers is to use place value. The whole number parts are the same. The decimal parts are both to the hundredths. Which decimal part is greater? Eleven hundredths is greater than 9/100ths. So 10 and 11/100ths is greater than 10 and 9/100ths. Sal had the faster time. How is comparing decimals the same as comparing whole numbers? For both decimals and whole numbers, you compare the digits by place value, starting at the greatest place value. Another way to compare decimals is to start at the left. Compare each place value. Look for the first place where the digits are different. 1/10 is greater than 0/10, so 10 and 11/100ths is greater than 10 and 9/100ths. When you compare decimals by place value, why is it important to begin comparing at the left? Comparing at the left compares the greatest place values. Now you know how to compare decimals.
All right, so let's go ahead and take a look at these. Now, when we're comparing decimals, always start from your biggest place value. And then you're going to compare moving towards your smallest place value, the same way we do with whole numbers. Let's go ahead and take a look at our notes and our guided practice here. So how do you compare decimals? Now I gave you an example, compare 0.17 and 0.2. So 17/100ths or 2/10ths. Now you can use a hundredths grid. So I drew them out. Here's 2 hundredths grids. And I drew 0.17 here. And I drew 0.2 here or 0.20. Remember, 2 10 rods, that's 2/10ths or 20 out of 100. So there are more shaded in the side with the 0.2 or 0.20 than there are in the 0.17. So the pink has fewer squares shaded, so 0.17 is less than 0.20. Now you can add that 0 placeholder right there so that they're both going out to the hundredths. If this was written out only to the tenths, like it was up here as 0.2, you can add that 0 placeholder in the end, and then it's easy to compare. Compare 17 to 20. Another way you can do this is by using a number line. So here's my number line from 0 to 0.1 to 0.2. So this is broken up into hundredths. Now I marked 0.17 and I marked 0.2, or what would be 0.20. Now, since the 0.17 comes before the 0.2 or 0.20 on the number line, again, 0.17 is less than that. Or we could use place value. So begin comparing from the whole number parts on the left and then the decimal parts after the decimal point. So 0.17 and 0.2 both have a 0 in the whole number section, so we can ignore that. And then we have our decimal point, and then we have our next digit after that. So the first digit after that is going to be the 10th place. So here I have a 1 in the 10th place, and here I have a 2 in the 10th place. Immediately I can stop. Since this is bigger, anything that comes after it is going to have less value because it's a smaller place value digit. So these, think of these, remember, as 10 rods, and these are little individual ones. 7 ones are not enough to equal one of my 10s. So this is going to be less. So 17 of my ones or 20 of my ones, 17 of them is going to be less. Since that 1 in the 10th place is less than the 2 in this 10th place, I already know that 0.17 is less than 0.2. Now, a couple important things to remember. Tenths are greater than hundredths because tenths skip count by groups of 10, but hundredths skip count by ones. So 0.1 is greater than 0.01. So think of this as 1 dime and 1 penny. A dime has more value than a penny. Now, the zeros at the end of a decimal have no value. What does that mean? So 0.4 is equal to 0.40, just like 4/10 is equal to 40 over 100, right? We just multiply by 10 and we get this fraction. They are equivalent. So it's the same thing as saying 4/10 and 0 hundredths. So since I don't have any hundredths, I don't need to tell you 0 hundredths. When I don't tell you that I have any hundredths, you already know that there's nothing in the hundredths place. So this is the same as this. The same amount of this shape is colored in. This is just cut up into smaller pieces, but they are equivalent. Now, that 0 not having any value is only true for decimals, only when it's the final digit. So you can't apply that anywhere else. But remember, just like these are equivalent fractions, these are equivalent decimals. For number 1, it says Sai says that 0.20 is greater than 0.2 because 20 is greater than 2. Do you agree? Explain. Well, no, just like we just said, 0.20 is 2/10, or sorry, 0.2 is 2/10, and 0.20 is 20 hundredths. So 2/10 and 20 hundredths are equivalent. We can knock off that final 0 because it's the same thing as saying we have 2/10 over here in both areas and 0 hundredths. Just because I didn't write the 0 hundredths on this number, that doesn't mean that this is greater than this. 0 has no value by itself. Let's take a look at a couple others. So remember, you want to start comparing from the first number that is different from the other. So here our whole number is 0 in both sections, so we can ignore the zeros. Then I have 7/10 here and I have 5/10 here. Since the 7/10 or 70, 0.70, is greater than 0.57. So 70 would be greater than 57. Remember, you can always add that 0 placeholder right there so that it's easier for you to compare. For number 3, 0.41 or 0.14. So 41 out of 100, 41 hundredths, or 14 hundredths. 41 hundredths is going to be greater than 14 hundredths because this has 4 of my tenths and then 1 of my hundredths, and this has only 1 of my tenths and 4 of my hundredths. For number 4, we can look at the whole number parts. This has a 6 and this has a 7. Now, I don't even need to look at anything else. My whole number parts are different. My greatest place value is different. That's all I need to pay attention to. So since I know that 7 is greater than 6, 6.28 is less than 7.31. I don't even need to compare the other digits. And for number 5, 1.1 is equal to 1.10. So this is 1 whole and 1/10 size piece. This is 1 whole and 10 out of my 100 pieces, which is the same thing as saying 1/10 of my whole. Remember, you can drop that 0, or you could add a 0 placeholder onto the end of this one. Either way, your decimals here are going to be equivalent to each other. Remember, if you get confused, look at these, it broken up into 10 pieces or it broken up into 100 pieces, and you'll see that they're made up of this, they've got the same amount colored in, and they're made up of the same total number. That's it for this lesson. If you guys have any questions, please let me know. Otherwise, have an amazing day, 4th grade. Take care. Bye-bye.